Hello, welcome to another lesson. In this lesson, we'll be covering cloud security basics. We'll explore AWS and Azure security fundamentals, common cloud misconfigurations, and S3 bucket security. Cloud security is critical because most organizations now use cloud services and misconfigurations can lead to massive data breaches. Now let's dive in. Why does cloud security matter? Cloud security is critical because 95% of organizations use cloud services such as AWS, Azure, and Google Cloud Platform. Also, 80% of data breaches involve cloud misconfigurations, not sophisticated hacks. But here is the problem. One misconfiguration can expose millions of records. And because of all this, we employ shared responsibility model, which means that cloud providers will secure infrastructure and you and me will secure our data and applications. Now let's consider the real world use cases. Capital One in 2019 leaked 100 million records through a misconfigured AWS web application firewall. Uber in 2016 had AWS keys exposed on GitHub, compromising 57 million users. Also, Tesla in 2018 left a Kubernetes console unsecured, exposing AWS credentials. These weren't sophisticated attacks. They were simple misconfigurations that could have been prevented. Now let's consider the AWS security fundamentals. The first one is Identity and Access Management, or IAM. Identity and Access Management controls who can access what in your AWS account. It uses users for individuals, groups to organize users, roles for applications, and policies to define permissions. It grants only the minimum permissions needed to users. It also enables multi-factor authentication for all users, especially the root accounts. The second service includes security groups and NACL. These are virtual firewalls controlling all inbound and outbound traffic. Security groups are stateful and protect individual stances. Network access control lists, or NACLs, are stateless and have subnet level protection. Also, they have default deny, that is, they only allow what is explicitly needed. Anything aside from that, they deny. The third service includes CloudTrail and CloudWatch. CloudTrail logs all API calls, that is, it stores who did what and when. The second one here is CloudWatch, and that monitors resources and triggers automated alerts, and they are both essential for incident response and compliance audits. The last one here is the KMS, which is the key management service. And this encrypts data at rest and in transit. It centrally manages encryption keys, and it audits the key usage through CloudTrail integration. Now let's consider the Azure security fundamentals. The first one we'll consider here is Azure Active Directory, which is Azure AD. And this includes identity and access management for all Azure resources, single sign-on or SSO and conditional access policies, multi-factor authentication enforcement, and identity protection at scale. The second one is network security groups, or NSGs, and this filter network traffic to and from Azure resources. It defines allow and deny rules by IP addresses and ports. It is also applied at subnet level or individual network interface card level, that is NIC level. The next one is the Azure Security Center, and this has unified security management and visibility dashboard. It also includes continuous security assessment with scored recommendations. Lastly, it has threat detection with automated remediation options. The fourth one is the Azure Key Vault, and this securely stores secrets, certificates, and encryption keys. It has granular access control and full audit login. It integrates with Azure services for seamless key retrieval. Lastly, we have Azure Monitor and Log Analytics. This collects and analyzes security logs across all services. It alerts on suspicious activities and threshold breaches, and it is also long-term because it has log retention for forensics. Now let's look at the shared responsibility model in cloud. What are the responsibilities of the cloud providers? They secure physical data centers and all hardware, network infrastructure and cabling, hypervisor and virtualization layer, and manage service security such as RDS, Lambda, and so on. And on the other hand, we have myself and you. And what are our responsibilities? 1. Data encryption and classification, identity and access management, network configuration such as security groups and firewalls, and S3 bucket permissions and policies. Here is the key you must not forget. Cloud providers secure the cloud of the cloud, and we secure what is in the cloud. A misconception is that it is in the cloud, so it is automatically secure. That is very wrong, because the reality is you are still fully responsible for securing your data and all configurations. If any mistakes happen, you are responsible for it, unless it is an infrastructure, data center, or hardware issue. Let's now consider the common cloud misconfigurations. The first one to consider is the publicly accessible storage such as S3 or blob. Now, S3 or blob storage set to public read or write can expose customer records, credentials, and backups. 47% of S3 buckets have some public exposure, so you need to be careful of that. Number 2, overly permissive IAM policies. Using allow in IAM policies grants full permissions to all resources. So admin access given to non-admin users can cause a big havoc. And this can also result into long-lived keys instead of temporary credentials. So when you're using the allow command or option, you should be careful of it. Number 3 is unencrypted data. An example is X3 buckets and database snapshots that are stored in plain text, or sensitive data transmitted without TLS or SSL. All of this can lead to an immediate breach because if it is readable and if an attacker can intercept and see that, it can lead to a big problem. Number 4 is exposed management interfaces. We have SSH for port 22 or RDP for 3389. If all these ports are open to 0.0.0/0, which is the entire internet, that is a problem. Also, database ports shouldn't be publicly accessible. Kubernetes dashboards should also be not without authentication. The last one here is disabled logging and monitoring. CloudTrail and Azure monitors everything we ask them to monitor on our cloud platform. So if you disable them to save costs, that's another big problem. Also, there should be alerts always. If there are no alerts for suspicious activity, that's another problem. And there should also be audit trail for compliance or incident response. Absence of that means that you are disabling logging and monitoring. Now let's consider the basics of S3 bucket security. Let's first consider what S3 is. What is S3? S3 is an object storage for files, backups, and static websites. It is organized into buckets, that is, each has its own access permissions. And for S3, default behavior has changed, that is, now all buckets are private by default since 2022. Let's now consider the S3 security layers. The first one is the bucket policies, and this includes JSON documents defining who can access the bucket. This can allow and deny by IP, accounts, or public. Second one is access control lists or ACLs. These are the older legacy permission system, so you should avoid them if possible because they grant read or write to AWS accounts or the public. Instead, I would advise you to use bucket policies instead of access control lists. For layer 3, block public access settings. That is, you should for toggles to prevent public exposure. And for toggles refers to the 4 fundamental security controls that must be configured or toggled on. Layer 4 is encryption. That is server-side encryption, and this means that AWS encrypts at rest. Client-side encryption means you encrypt before uploading, and encryption in transit requires HTTPS. Layer 5 is versioning and multi-factor authentication delete. Versioning keeps multiple versions so that you can recover from deletion. MFA delete requires multi-factor authentication to permanently delete data. Now let's consider the S3 bucket misconfigurations. So let's see how S3 buckets actually get compromised. Misconfiguration number 1 is public read or write access. This policy allows anyone on the internet to read files. It is fine for public websites, but catastrophic for sensitive data. Misconfiguration number 2 is overly permissive bucket policies, that is granting full control to anyone because attackers can upload malware or wipe your entire bucket. Misconfiguration number 3 is disabling public access block settings. This means that when all four toggles are off, even well-intentioned policies can be overridden. Misconfiguration number 4 is no encryption. That is, if data is stored in plain text, this means that attackers can immediately read everything if the bucket is breached. And you might be wondering, how do attackers find vulnerable buckets? They do that by using automated scanners like Grey Hat Warfare, Google Dorking, and DNS enumeration. Millions of buckets are scanned on a daily basis. Now let's consider the best practices when securing S3 buckets. Number 1. Enable block public access for all four settings at both account and bucket level. Number 2. Use identity and access management roles instead of access keys. Never hardcode access keys in your code. Number 3. Implement least privilege bucket policies, that is, grant only minimum permissions, restrict IP or VPC, and require MFA or HTTPS. Number 4. Enable server-side encryption. SSE S3 is free, and you can use SSE KMS for compliance. Also, enforce encryption through bucket policies. Number 5 is enable logging and monitoring. X3 server access logs track requests. CloudTrail logs API calls. CloudWatch alerts on unusual patterns. Number 6 is enable versioning and MFA deletes. Number 7 is that you should conduct regular security audits using AWS Trusted Advisor and third-party tools like Prowler, ScoutSuite, and CloudMapper. Now let's wrap up with an essential cloud security checklist. The first one is identity and access. For this, enable MFA for all users, especially root, implement least privilege IAM policies, rotate access keys every 90 days, use IAM roles instead of long-lived credentials, and delete unused users and keys. Number 2, network security. And for this, configure security groups to deny all by default. Never expose SSH or RDP to the internet. Use VPCs and private subnets for sensitive resources. And enable VPC flow logs. Number 3 is data protection. For this, encrypt all data at rest, enforce HTTPS for data in transit, enable S3 block public access on all buckets, and maintain regular encrypted backups. Number 4 is monitoring and logging. For this, enable CloudTrail or Azure Monitor in all regions. Configure CloudWatch or Azure Alerts for anomalies, centralize logs in a dedicated security account, and set up automated incident response. For compliance and governance, always conduct regular security audits and penetration testing. Use automated compliance checks with AWS coding or Azure policy, document and review security policies quarterly, and provide security awareness training to all employees. That's all for this lesson, but before we go, here is a challenge question. And the question is, what is the difference between AWS security groups and network access control lists or network ACL? I repeat, what is the difference between AWS security groups and network access control lists? I'll be expecting to see the answer to the challenge question in the comment section. Thank you for seeing the video till the end. If you're yet to subscribe to our YouTube channel, please do that now. Also, do not forget to like, share, and comment. Thank you so much and see you in the next lesson.